Okay, so we're going to start with Module 1.1, which is solving equations. And so we're just going to take the first section and we're going to look at how we can deal with solving equations. Now, to go along with that, we have our goal, which means that the learner is going to know how to use the order of operations and properties of equality to solve one and two-step equations. So we're going to kind of get started with some basics, kind of refresh of previous work in order to solve one-step and two-step equations. So our next piece of vocab that we're going to focus on are equations. So obviously we've talked about equations before, you've been introduced to equations before, but the idea is that we have to understand what the difference is between an equation and an expression. So first of all, an equation is a mathematical sentence that uses an equal sign in order to show that two expressions, not equations, but two expressions, are equal to each other. So the idea is that this guy right here gives us our equal sign to make us have an equation. Now the idea here is that it says that are two expressions. So when you look at these two things, this here, this is an expression, and this 7 by itself is also an expression. So notice that they can be two different parts. Even though they don't have the same stuff, they still have the same idea of being an expression. Now, a couple of things that we have to understand. Obviously, this here is a variable, so make sure that we understand that that is a variable. The 3 and the 7 are known as constants. And then we have the item in front of our variable. Remember, that is called our coefficient. That's the number that's multiplying by the variable to continue everything on there. But the idea is that this is the basic setup and the basic components of what an equation is. And notice that the only difference here is that we have something that is equal, so we have to remain equal, and that's what leads us into properties to be able to continue everything being equal. So next of all, we have our properties of equality. There are 4 different properties that all kind of do the same thing, but with different respect to what you're changing. And so with an equation that we have, so any kind of equation that we end up building with, we have addition, multiplication, subtraction, and division. Each one of them do different things, but they all accomplish the same goal by maintaining equality. And basically all 4 of these accomplish the same thing. So you can see the addition property, you're going to add the same value to both sides of an equation. With our subtraction, you're basically going to do the same thing. So you're going to subtract the same value from both sides. And then with multiplication and division, it's kind of the same idea, is that you're going to multiply or you're going to divide in an attempt to keep equation equal. So the idea behind properties of equality is to maintain that equality. So when you add, subtract, multiply, or divide on one side of the equation, obviously that tips the balance to the other side, and we need to do that on the opposite side of the equation to maintain that equality so that the values or the equation doesn't change what it's supposed to be. So we have our 4 properties of equality that we're working with. Now these are your properties of equalities and the way that they kind of look when we actually put a number to them. So I'm going to, by force of magic, I'm going to show you how these kind of will look once we kind of have all of these things in there, and then we'll talk about each one of them individually. So 1, 2, 3. Now if you look at all these together, you can see that no matter whether we add, subtract, multiply, divide any particular number, the statement remains true in each one of these scenarios. Now with the algebra side of it, even though it's kind of harder to see it that way, but with the algebra piece of each one of these, the idea is that those remain the same. So if you're taking something that's already true and then you're just multiplying or adding or subtracting or dividing the same thing to it, nothing's going to happen to it. Everything will stay the same. So the idea of properties of equality, whatever you do to one side, you must do to the other side. So as we use these, we can solve some basic one-step equations. Now, most of you could probably look at this equation already and you can already tell me the answer, and I can just go ahead and tell you right now the answer is that x equals 10. Now you can clearly see that if you plug in 10 and then you subtract 6, that is going to give you 4. But the idea of what we're trying to look for is we're looking for what is the solution. So when we're trying to look for a solution, the solution isn't necessarily just a number or just anything else. The idea is that we have to understand how we check our answer. So one of the things that we need to talk about first, and this is just kind of getting a vocab out of here, solutions make what we call true statements. So the idea behind this is that in order for us to be able to decide that we do have a solution, we need to come up with a true statement with our original equation. And so I'm going to use my properties of equality in order to solve this. And so the idea here is that I'm subtracting 6, so I'm going to add 6 to both sides. So I did it on this side, so I'm going to also have to do it on this side. And so that gives me these cancel, and I get x equals 10. And so the idea is that this is my proposed solution. So in order for me to check this, what I have to do is I have to take this original answer and I have to plug it back into my equation. So I have 10 minus 6 equals 4, and then I get 4 equals 4. Now this right here is what we're talking about. Here, this is the true statement. So once we get that true statement, we know for a fact that 10 is a solution. So the idea behind this is not necessarily to show you how to do a one-step equation, but for you to understand that if we have to recognize what a solution is. Now, moving on to two-step equations. Now, we may have seen some two-step equations before, but we're just going to make sure that we identify and properly identify our properties and our order of operations in order to solve these. Now, the idea behind a two-step equation is that we need to be able to solve and we need to be able to check what this variable is here, this x. We want to know what that value is. Now, we could guess and check and we could keep plugging in until we get an answer that is just fine for what we need, but we need to take this one step further. We need to actually use our properties to solve this. So the first thing that we're going to do in order to do this is we're going to simplify if there's anything that needs to be simplified. Maybe we might need to distribute, maybe we might need to add and subtract some like terms that are all on one side, but in this case we don't. Everything is clearly the way that it needs to be. Now, in order for us to do two-step equations, we're going to clear addition and subtraction first. So the idea behind this is that you're going to actually do your order of operations in reverse, because the way that this was supposed to work is that if I knew what this number is, I would have to do this first, but I can't because there's nothing there. And so I'm going to make sure that I get, and I'll show you how I do this, is that I'll box this around and say, okay, I need to get this all by itself. So I'm going to clear any addition or subtraction that is near this box. And so we can see that we're subtracting 2. So the opposite of that, in order for us to do this, is we need to get rid of that. We need to do the inverse operation. So if we're subtracting 2, then we would need to go ahead and we need to add 2. Now, because we did it on one side, we also need to do this on the other side. So if we're going to add 2 over here, we need to add 2 on the opposite side. Now, I like to use vertical addition here so that we can clearly see what's happening here. So these two are opposite and they cancel each other. Then we have 3x equaling 7 plus 2, which is 9. So we cleared any addition or subtraction that is around. We can look at this step and we can say, okay, there's no more addition, there's no more subtraction. The next thing that we're going to do is we're going to clear any multiplication or any division. So the idea behind this is now we're looking for multiplication and division and doing the inverse of that. So in order for us to do this, we see that we're multiplying 3 times x, so the inverse of that is to divide by 3. Now I can make a fraction, or I can show a division bar, or I can show the division symbol. It doesn't matter. But the idea here is to maintain equality. So if I do this on one side, I also do need to do this on the other side. So I'm going to divide by 3 over here. 3 divided by 3 cancels out to 1. So we're going to say 1x. 9 divided by 3 is 3. So now we have x all by itself with a 1 there. That doesn't matter. But now we do need to check our answer, check our solution. So we take this original value here and plug it in to our original equation. 3 times 3 minus 2, does that equal 7? And so the way that we do this is we go through our order of operations. 9 minus 2 equals 7. 7 equals 7. I'm going to put a check mark there. That is a true statement, so that means that x equals 3 is our solution. Now, as we look at our two-step equations, remember, we're always doing things in reverse. We're unpacking the problem. We're unpacking the equation so that we can make sure that we remain equal, but we also get back down to what is the variable, what is it that we're trying to find, what are the properties that I'm going to use. And so the idea here is that I always like to isolate the variable by itself by putting a box around it. So I'm going to find the variable, I'm going to find what is known as the variable term, the piece together where that variable is, and I'm going to try to get that by itself first. So if we remember our order of operations and we kind of go backwards with that, what we need to do first is we need to clear out any addition or subtraction by using the inverse operation. So in this case here, we have a subtracting 10 that is near and around this x that we need to get rid of. And so in order for us to do this, we're always going to do the opposite of what we want, or the inverse of what we want. So if we're subtracting 10, we need to add 10 in order to eliminate that and move it aside. And by doing that, you can see that adding 10 and subtracting 10 will just cancel each other out. But to remain equal, to keep that equality that we need to do that to the other side of the equal sign. So don't just do this to the next number over. That's the very thing that you need to be careful of. We need to do it to the other side of the equal sign. I'll put a line under it so we can add these together. This just drops down, so we have 5x. These two are opposites, so they're going to go away. And then we have equal to 30. Now, if we just look at this expression, or we look at this equation that we have here, we just have 5 times an x equaling 30, which brings us to our next set, where we're going to get rid of multiplication and division. And so the idea here is that we have our variable that we're trying to isolate. So now that we've kind of moved out of that box, we can move inside of that box and try to get just that variable x by itself. Now, if we notice that this is 5 times x, so in order to get rid of that, in order to remove that, we need to do the inverse operation, which would end up being dividing by 5. So we're going to divide by 5 on both sides of the equal sign. If it helps you to draw a little line through here so that you can make sure that you're on both sides, then that works too as well. 5 divided by 5, that cancels itself out, so the x just drops down. We have x equals 30 divided by 5, which ends up being 6. Now, the idea behind this is that we can check that to make sure that it's correct, but we just want to focus on maintaining whether or not we know how to solve our two-step equations. And then for our final example, we have 9 minus c equaling negative 13. So the process is still going to be the same. There's only going to be one catch. The only catch here is notice that the variable itself is right there. Now, the one problem that a lot of you are going to run into is that you're going to put a box right around this variable like this, and you're going to say, okay, well, I've got a 9 there. It's a positive 9, so in order for me to get rid of a positive 9, just like I used to do with my one-step equations, I would just say minus 9. And you would be correct. This is the way that we would end up doing this. So we would subtract 9 from one side and subtract 9 from the other side. However, a lot of you will make the mistake of saying that c is equal to, and then you subtract those together, which would give you negative 22, and you would say that that is your answer. However, what you have to be careful of is that this subtraction symbol doesn't really actually go away. So what happens is that instead of it just kind of disappearing, what it does is it carries along, and it actually belongs to the variable itself. So this would end up being a negative c, or for some of you that like to see it this way, negative 1 times c equaling negative 22. So that has to come along with this. So operations go along with variables. They can distinguish being positive and they can distinguish being negative, which will help us in our solving process. Because if you were to look at c equals negative 22, like I showed you, you tried to plug that back in, you wouldn't get the correct answer. You'd get something completely different. And so the idea behind this is that we can continue solving this now. So instead, we just need to divide by -1 on both sides, and the answer is very similar to that. However, now it's a positive answer instead of a negative answer, and if we check that, 9 minus 22, does that equal -13? And we will find out that -13 equals -13. So you just have to be very careful, and those are examples that we'll also go over during our class time. So just a couple of things to talk about right before we wrap this up. So remember, we have 4 different properties of equality. We have addition, subtraction, multiplication, and division, which will all do something different but also maintain inequality. Remember your order of operations, your PEMDAS. That multiplication and addition subtraction get done simultaneously, but when we're solving, when we want to solve an equation, we have to unpack it and we have to go backwards. So the idea is that remember your order of operations because we always use it. And then solutions, remember solutions make true statements. If you don't get a true statement out of any of your answers, when you check those again, those aren't your solution, it's something else. So that's going to wrap it up for this video for our first modular of 1.1.